Have you ever stopped to think about what actually happens in that split second after you hit enter? I mean, it really feels like magic, right? But it's not. It's this beautifully orchestrated, hidden conversation. Today, we're going to pull back the curtain and decode the secret language of the internet, the OSI model. So, picture this. You type in a website, you hit enter, and poof. A web page from maybe halfway across the planet just appears on your screen. But how? How in the world does your Apple laptop have a conversation with some Linux server it's never even met? Well, that's the exact mystery we're going to unravel right now. You know, the biggest challenge the internet had to solve was this. How do you get billions of different devices made by thousands of different companies, all using different tech, to speak the same language? Without a common set of rules, the internet would just be total chaos, a digital Tower of Babel, really. The easiest way to wrap your head around this is to think about a global postal system. Look, you don't need to know how the mail trucks work or what route they're going to take. You just have to put the right address on the envelope, and you trust that the system will figure out the rest. The internet needed a set of rules just like that. And that system is the Open Systems Interconnection Model, or what we all call the OSI model. Now, it's really important to get this. You can't go out and buy an OSI model. It's not a physical thing. It's a conceptual framework, a 7-layer rulebook that makes sure all the different hardware and software can play nicely together. It's the blueprint for how networks talk. All right, let's do this. We're going to follow one little piece of data on its incredible journey. And we're going to start at the very top with the layers that are closest to you, the user. This is right where your request to see that web page is born. And so we begin our descent at the very top, layer 7, the application layer. This is your world. It's the only layer you actually see and touch. When you're typing in your web browser or checking your email, you're right here. Its main job is to kick off the conversation using protocols, which are really just agreed upon rules, like HTTP. HTTP basically tells the network, hey, I want to grab the data for this website, figuring out what you want and who you need to talk to. Okay, our request is made. Now, it gets handed down one level to layer 6, the presentation layer. Just think of this layer as the network's universal translator. The server you're talking to might be speaking a different data language, so this layer translates your request into a standard format that everyone can agree on. It's also the security guard, handling encryption to scramble the data, and the professional packer, compressing the data to make it smaller and faster to send. Dropping down one more level, we land at layer 5, the session layer. This layer is basically the conversations project manager. Its job is to open up a dedicated line, a session, between your computer and the server. It keeps that line open just long enough for all the information to get across, and then it shuts it down neatly. And here's the really cool part. It sets checkpoints, so if your download gets interrupted, it can just pick up where it left off instead of starting all over again. Super smart. So, our message is now translated, secured, and ready to go. But how does it actually get where it's going? Well, now it needs to be properly packaged and addressed for the big trip across the internet. And that's where these middle layers come in. Welcome to the engine room, layer 4, the transport layer. If we're sticking with our postal analogy, this is the main sorting facility, the place that's obsessed with quality control. The transport layer takes that big chunk of data from above and chops it up into smaller, numbered pieces called segments. It also handles flow control, making sure you don't overwhelm the other computer by sending data too fast. And it does error checking to make sure all those little segments arrive safely and get put back together in the right order. Now, here at layer 4, you've got two main flavors. First, there's TCP. Think of TCP as sending a package with registered mail. It's super reliable, you get delivery confirmation, it guarantees every single piece gets there. Then you have UDP. UDP is more like tossing a postcard in the mailbox. It's way faster and lighter, but there's no guarantee it'll arrive. You'd want reliable TCP for a website for sure, but you'd use speedy UDP for something like a live video stream, where losing a tiny bit of data isn't the end of the world. Okay, our data is all segmented up and ready. We're now moving down to layer 3, the network layer. You can think of this as the global GPS for all of your data.
This is where the internet part of the internet really happens. The network layer takes those segments, puts them into little digital envelopes called packets, and stamps each one with the destination IP address. That IP address is the unique global address for the server you're trying to find on the vast map of the internet. The main job here is routing, finding the absolute best, most efficient path for your packets to travel.
We are so close. Our data packet has its global address and it's ready to go. Now we just have to get it from the software inside our computer out onto the physical network, the actual wires and the airwaves.
First stop, layer 2, the data link layer. Now, if the network layer was the global GPS that got us to the right city, this layer is the local mail carrier who knows every single house on one specific street. So what the data link layer does is it takes those IP packets and puts them into another container called a frame. And this frame is addressed with a local physical MAC address. A MAC address is a totally unique serial number that's burned right into your computer's network card. So the IP address gets the packet to the right building, but the MAC address gets it to the right person's desk inside. This is where stuff like Ethernet and Wi-Fi live and work. And at last, we've hit rock bottom, layer 1, the physical layer. This is where all the digital talk turns into actual physical reality. This layer doesn't care about concepts like packets or frames. It just sees a long string of ones and zeros, bits. Its entire job is to turn those bits into a physical signal. We're talking about tiny electrical pulses zapping down a copper cable, flashes of light shooting through a fiber optic line, or radio waves beaming through the air for your Wi-Fi. This is the raw physics of it all. Okay, let's take a quick breath and put this whole incredible journey together. As your data travels down from the top at layer 7 to the bottom at layer 1, each layer adds its own little wrapper of information. This process has a name. It's called encapsulation. Honestly, the best way to picture it is like a set of Russian nesting dolls. You start with your data, layer 4 wraps it in a TCP shell. Layer 3 then wraps that in an even bigger IP shell. Then layer 2 comes along and wraps the whole thing in a final frame shell. And then layer 1 just takes that finished doll and blasts it across the network as a stream of bits. On the other end, the server just does the whole thing in reverse, opening each doll one by one until it gets to your original message inside. So you see, this 7-layer model is so much more than just some dry diagram for a tech certification. It's the invisible logic, the ghost in the machine, that makes our entire digital world possible. Every single time you send an email or watch a video, you're watching this beautiful 7-step dance play out. It's the universal blueprint that lets us all connect and create. And it really just leaves you with one question. What part will you build?